Okay, hello guys. Welcome to today's our topic about simultaneous equations. Okay, so let's move into the first part about linear and nonlinear equation. So here we have on the left is for a linear equation that is mx plus c, and another is for a nonlinear, like a quadratic form that is ax squared plus bx plus d. And then you can just try to solve them and to put them on the one side, that becomes ax squared plus b minus mx plus d minus c. Okay, that equals to 0. So here we can set that the discriminant here equals to b minus m squared minus 4a times d plus c, right? Okay. And we can set here, we can just try to understand it as a total or a very simple quadratic form, okay? Like ax squared minus bx plus c equals to 0. So we can say here, we can try to solve for the x and trying to understanding how to calculate it as clear as possible, right? Just using discriminant. So also in last lesson, we learned that the discriminant bigger than 0 means there's two solutions, and discriminant equals to 0 means there's only one point, and discriminant equals to or smaller than 0 is like there's no solutions and there's base on the curve, okay? So like for example, like here, for this example, like the line y equals 2x and plus y, and y equals to x squared minus x minus that. And you can just try to put the two equations together because the intercept means that they're passing through 2 points and they have a solution of x, right? And then you can try to remove it as x squared. And then applying here we have two solutions, that is x equals to 5 or x equals to -2, right? So we can say here there's 2 points for 5, 11, and -2, -3, okay? That is how we can just try to solve the points position in here, okay? And then we can say here's another example, like the line y equals to 4x minus 5 has a tangent to y equals to x squared minus 1. So you can first try to make them together like this way. And then trying to rearrange it as x squared minus 4x plus 4 equals to 0. And then you can just say that because there's a tangent, there's only one intercept, means there's only one root, right? So the discriminant here equals to -4 squared minus 4 times a times c equals to 0, okay? So there's only one intercept and the line is a tangent, okay? So let's move into the next part about finding a line in tangent. So that here maybe we have y equals to kx, and here's a tangent to y equals to x squared minus 2x plus 9. So we can say here x squared minus 2x equals to kx, and rearrange it as x squared minus 2 plus kx plus 9 equals to 0. So it's 2 plus k squared minus 4 times a times c equals to 0. And then you can solve that k equals to 4 or k equals to -8. That means two roots or two solutions for k that can obey the rules for x right here. Okay, so there's only one tangent. Okay, and for the three exercises, if you want to try yourself, you can keep on going. Okay, so if you want to follow with me, you can just go on with me. Okay, so let's move to the first problem. So here, solving the simultaneous equations for y equals to x minus 3 and y equals to x squared minus 5x plus 2, right? So you can just try to put them together like here. The x squared minus 6x plus 5 equals to 0. So you can find x equals to 1 or x equals to 5, right? And for second problem, because it's a tangent, so you can just try to just connect two equations together, and it's 2x squared plus 4x minus c equals to 0. So discriminant equals to 4 squared minus 4 times 2 times negative c, right? It equals to 16 plus 8c equals to 0. So c equals to -2, okay? That is how we can calculate exactly c right here, okay? So that's for our exercises and the solutions here. You can just try to check it, okay? So that's for this our lesson. See you next time. Bye.